All right. So, let's say that I get my first job and I work for Dunkin' Donuts. Believe it or not, it's a possibility. And I'm in their laboratory and I'm given a food product that Dunkin' Donuts wants to put on their menu. That food product has to undergo analysis for nutritional content. So on the back of a nutrition label, you'll see that. This is how many grams of carbohydrate. This is how many grams of fat. This is how many grams of sugar. All of that's got to be done in a laboratory environment, and all of that either is done in-house with the company itself, if they have money to do a laboratory, or they have to outsource that to a different laboratory that specializes in the food product industry. So there's a possibility that you could be testing for a food product like that one. And in this example, we're going to work through reporting a confidence interval. So I'm in the laboratory and I'm given this product. This product, well, it's a fancy term. They call it glycoprotein. What's a glycoprotein? Well, you eat it. It's protein. Glyco, think sugar. So I take this and I take it into the laboratory and I analyze it for the protein content. And these are the values that I get. 12.6, 11.9, 13.0, 12.7, and 12.5. Notice they're all different. That's understandable, right? There's different errors. I handle samples a different way. Things can happen with the transfers, but overall in total they're all really close together, right? They're in the 12 to 13 vicinity. It's my job to report what the findings are. I know that I can't report just one number and say this is the answer because I would be lying. But I can say this is the answer that I've got, and the true value lies in this window somewhere. Don't really know where, but it lies within the window. That's the purpose of the confidence interval. So we're going to go through and we're going to calculate the 50% and the 90% confidence interval for this set of numbers. All right, so before we start, we need to go back and we need to review what this equation is. And the equation, number one, I have to have my average plus or minus t s over square root of n. All right, so I know that my x bar is the average. I know that the s is my standard deviation. The t comes from the student t chart, and the n is the number of measurements. So I like to write that over to the side because the more I write it, the more I will understand it, and the quicker I will learn it. All right, so we're going to have to do an average of these numbers, and we're going to have to do a standard deviation of these numbers, and you can do that by hand if you want to, but why would you want to be that crazy? You've got a calculator that can do it for you, or you've got Excel that can do it for you as well. So I just want to use Excel to do it, just to kind of bring back Excel and get you more familiar with it, to tell you it is not the devil. So I'm just going to key in the numbers. 12.6, and I did it again. 11.9, I did it again. It was 13. I did another test. It was 12.7, and another test, 12.5. So this student T, or confidence interval, requires an average. So I'm going to come over here to the side. I'm just going to type the word average in so I know what this number is supposed to represent. I want Excel to do the average for me, so I need it to do a calculation. When I need it to do a calculation, I start off with equal, and then I need to tell Excel what to do. So I need to do an average, so I spell it out, and I open the parentheses up. Well, I need to tell it what to do the average of. That's what it's waiting on. That's why it says number one, number two, dot, dot, dot. So I just highlight the cells, and I hit enter, or I close up the parentheses, Let me expand that so you can see it a little better. Then I hit enter. There's my average, 12.54. Saves me a little bit of work. I also need the standard deviation. So instead of writing out standard deviation, I just type in STDEV. I want it to do the calculation for me. I don't want to do the standard deviation by hand. Are you crazy? Equals STDEV. Open the parentheses up. And again, it's waiting for the numbers. So I highlight them, close the parentheses back, hit enter. There's my standard deviation. Okay. There's the two pieces of the puzzle that were kind of missing that really was the most work. Excel made quick work out of it, though. You just had to use it. So 12.54 is the average. So I'm going to come up here. 12.54. My standard deviation was 0.40. Remember, smaller standard deviation means that your numbers are really close together. A 0.4 means that the numbers were close, but not too close, right? That's a 0.4. 0.04, then your numbers would have been super, super close together. And now I need two other variables, a t number and an n number. Well, the n is really easy. That's the number of measurements that I took. So 1, 2, 3, 4, and 5. I did this thing 5 times, right? I had 5 numbers that I took the average of. 1, 2, 3, 4, 5. I had 5 numbers that I took the standard deviation of. 1, 2, 3, 4, 5. So n is going to be 5. Now the question said we got to calculate the confidence interval at the 50 and the 90%. Well, there's a t number for each one of those. So there's going to be a 50%, and I'm just going to write that in a different color. And then there's going to be a 90%. It wants me to do both. I've got to get the t's for both of those. Everything else stays the same, though. The average is the same for both. Standard deviation is the same for both. The number of measurements is the same for both. It's the t value that changes. One's t value is going to be for 50, and one t value is going to be for 90. All right, well, where do I get those numbers? Well, those numbers come from the chart. Here we go. There's a chart. I need 50%, so there's my 50. And I said I had 5 measurements, but be careful. 5 measurements means 5 minus 1, 4 degrees of freedom. So I need to go to the 4 row, and I come across, and there is my degrees of freedom at 4, and that is a 0.741. So here on my sheet of paper, 0.741 is the number that I will use for my 50% confidence interval. All right, well, what about my 90%? Well, I do the same thing. Here's my 90% column. I go down to 4 degrees of freedom because I had 5 measurements. And I go over, and I will pick 2.132. That is the t number that I will use there, 2.132. So 2.132. All right, so that's how I use the table. See, it wasn't that difficult. I just got to know where to find my numbers and how to interpret the chart. So now I'm going to come down here to the bottom, and I'm going to actually solve for one of these at least. So my x bar is 12.54. That's my average, plus or minus my student t. Let's do 50% first. We're going to do 50% confidence interval. So that's a 0.741 times my standard deviation, which is 0.4, divided by the square root of n, which is 5. Once you have your numbers written on the side, you just got to put them into where they need to go. Okay, well, let's take a look then at the calculator portion. I'll bring up the calculator over here. Notice nothing really happens to this 12.54. It just stays as 12.54 for now, plus or minus. I need to simplify this whole mess up, right? This is my window. This is really what my confidence interval is doing. So this is going to determine my minimum and my maximum. So in the calculator, what I can do is I'll take 0.741 multiplied by 0.4, and I hit enter, and that will give me 0.2964. And then I'm going to divide that by the square root of 5. You got to be careful in the calculators though. You want to make sure that you do the order of operations and that it's interpreting it the right way. So we are going to divide that by parentheses. And I need to put in the square root of 5. Well, this calculator is a little weird. The way that I have to enter it in here is 5 to the 1 divided by 2. Close it up, it's a half. Close it up again. That's 2.236. And then I hit enter. 0.132. So if you've got a calculator that will do that for you, you'll be able to see it a little bit easier versus the computer calculator that I can show on the screen. But take it in baby steps. If you don't know how to enter it into the calculator, let me know, or let someone in the lab know. They will be able to help you. So swing by the office, that's what I'm there for. So 12.54 plus or minus 0.132. That is the confidence interval, which means that 12.54 is the number that I have gotten. So if I take 12.54 and I subtract 0.13 from it, I'll get 12.41. Right? This is plus or minus. All right? If I take 12.54 and I add 0.13 to it, I get 12.67. That gives me my minimum and my maximum. So that means that on a sheet of paper, when I've done this test, 12.54 is the number that I'm reporting. I know that that number is not correct. I know that number has error with it. I know that number is not the true value, but I can give you a 50% confidence interval. I'm 50% certain, half. 50% certain that the true value, whatever the true value is in between 12.41 to 12.67. It's somewhere within that interval or that window. 50% certain of it. All right, well, the question also says, okay, well, what about the 90% confidence interval? How does that change anything? Well, it's still 12.54 plus or minus. My student T, though, is changing here, 2.132. The rest of everything else is the same. Standard deviation is the same. The number of measurements are the same. So this is 12.54 plus or minus. I'll pull up the calculator again and do it for you. 2.132 times 0.4 is 0.8528 divided by square root of 5. So 12.54 plus or minus, and let's clean that up over there. I know this seems like a mess on the computer calculator, and it is, trust me. 0.8528 divided by, I'm going to put the parentheses on it, 5 to the parentheses 1/2 is how we have to enter it in here. I know, It's awful. Then I hit enter and I get 0.38. So look at what happened to my window. 50% certain my window's a 0.13. If I go to 90% certain, I better feel better about my number, about the result that I'm reporting, so my window becomes larger. And when my window becomes larger, I'm a little bit better as far as knowing that my true value is in that range somewhere. So again, what I would do is that I would take 12.54 minus 0.38, and that gives me a 12.16, all the way to 12.54 plus 0.38, and that gives me 12.92. So my window has become larger. And because my window has become larger, I feel better about the actual true value in that window somewhere. So now I'm telling a company, well, I did the testing, 12.54 is what I've got, but I'm 90% certain that the true value of this object or this sample that you gave me is between 12.16 to 12.92. It's in that window, it's in that range somewhere. And that is what we call the confidence interval. So this is two examples, really, using the same kind of numbers: average, standard deviation, number of measurements, and student t. And this is how you will pick a window or a confidence interval to report. Again, keep in mind, this question told you which ones to use, 50 and 90. If it does not tell you which ones to use, you use 95 by default every single time. So when a question says calculate the confidence interval or calculate the confidence limit, this is the process that you go through. As a last resort, if I type in equal and I start typing in confidence, notice there is a confidence listed in Excel. Do not use confidence limit in Excel, please. It will give you the wrong answer. Ha 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 ha. And I'll know if you did it because you'll report that answer. And I know what that answer is going to be because people have done it in the past. Do not shortcut the confidence interval calculation. Do the confidence interval by hand every time. Do not use the Excel version because it reports it in a different way. So lay off of it. Let Excel calculate the average and standard deviation, but do not let it calculate confidence interval. You'll get it wrong. And you don't want wrong answers.